Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.68. While solving this problem, we will be using total series resistance calculation formula. R equivalent of a series connection is calculated by taking the sum of all resistances connected in series connection. We also will be using Ohm's law. According to Ohm's law, voltage across any resistance R is always equal to the product of current through that resistance and the value of resistance. Now move towards the problem. Exercise problem number 2.68. Find current I1 and voltage V0 in given below figure. This is the circuit diagram of given problem. We have to find current I1 inside this branch and voltage V0 across this 4 kilo ohm resistance inside this network. So without wasting time, let's proceed towards the solution. First of all, we will try to find current I1 inside this branch and current I2 through this branch so that we can calculate voltage across this 4 kilo ohm resistance as well. For that purpose, we will simplify this network. These two resistances are connected in series connection. So we can find their equivalent resistance and replace that equivalent resistance with these two resistances in order to simplify the circuit. Sum of these two resistances will be equal to 6 kilo ohm. So we can replace these two resistances with a single resistance having the value of 6 kilo ohm. Now this voltage source is connected parallel to this branch as well as this branch. So we can calculate the currents of both branches. For the identification of currents, this branch current is already labeled as I1 and this branch current will be assumed as I2. Now we will use Ohm's law to calculate these currents. Current I1 will be equal to 6 divided by the value of resistance in this branch, that is 12 kilo ohm. So the value of current I1 will be 0.5 milliampere. We have calculated one parameter that was highlighted in the question. The other parameter is voltage across this 4 kilo ohm resistance. For that purpose, we should have the value of current through this branch. And that current is equal to I2 and we will calculate this current using Ohm's law again. Value of current I2 will be equal to 6 volt divided by the value of total resistance in this branch, that is 6 kilo ohm. I2 is equal to 6 divided by 6k. So the value of current I2 will become 1 milliampere. We have calculated the value of current I2, that is 1 milliampere, and this same current will flow from both resistances because of series connection. So we have current through this resistance. Value of resistance is already provided. So we can calculate voltage across this resistance using Ohm's law. Voltage across this resistance will be equal to the product of current through it, that is 1 milliampere, and the value of resistance, that is 4 kilo ohm. Take the product of 1 milliampere and 4k, it will become 4 volt. So 4 volt is appearing across this 4 kilo ohm resistance and 0.5 milliampere current is flowing through this branch. So this was exercise problem number 2.68. Thank you. See you again in next video.